Hi everyone, this is Christiana Malta, and for today's video, I'll be solving sets of problems under electrostatic and capacitance. So for the first problem, we have here problem number 1. Calculate the electrostatic force or repulsion between two alpha particles when at a distance of 10 raised to negative 13 meter from each other. Charge of an alpha particles is 3.2 times 10 raised to negative 12 coulombs. If mass of each particle is 6.68 times 10 raised to negative 27 Newton meter squared per kilogram squared. So first, let's have the given. So the given distance of D is equal to 10 raised to negative 13 meter. And for the charge of an alpha particles, we have here Q1 is equal to Q2. Why is it? It is because the problem says alpha particles, and when alpha particles, it means that the charge are identical. So they are identical. So we have here Q1 is equal to Q2. So, and it is 3.2 times 10 raised to negative 12 coulombs. And for the mass also, we have here M1 is equal to M2, and it is 6.68 times 10 raised to negative 27 Newton meter squared per kilogram squared. And for this problem, to calculate the electrostatic force, we will be using the Coulomb's law, wherein it says that the second law of electrostatics states that the force of attraction or repulsion between charges is directly proportional to the product of two charges and is inversely proportional to the square of the distance between them. So for the formula, it is F is equal to K Q1 times Q2 over D squared. So substituting all the given value to the formula, so and for the K, we have here for the value of the constant, so we have here K is equal to 9 times 10 to the power of 9, and it is in Newton meter squared per coulomb squared. So it is 9 times 10 to the power of 9 Newton meter squared per coulomb squared multiplied to, for our Q1, it is 3.2 times 10 raised to negative 12 coulombs. And for our Q2, it is 3.2 times 10 to the power of negative 12 coulombs divided by 10 raised to negative 13 meters squared. So plug this value on the calculators, we will get 9.216 times 10 to the power of 12 Newton. So meter squared here will be cancelled out, and also for the coulomb squared. And it is our force of repulsion. And the problem also has the given value of mass, so we can also get the value of force using the given of mass. So we will be using this formula. The gravitational force is equal to J, and is directly proportional to the M1, product of M1 and M2, and is inversely proportional to the distance, to the square of the distance. So for the value of J, we have here in the calculator constant number 39. It is, for our J, we have here J is equal to 6.67428 times 10 to the power of negative 11. So plug the given value of mass to our formulas, we will get, for our J, we have here 6.67428 times 10 to the power of negative 11. For our value of mass, we have here 6.68 times 10 raised to negative 27 kilogram. And for our M2 also, we have 6.68 times 10 raised to negative 27 kilogram. And for our distance, we have 10 raised to negative 13 meters squared. And plug this one into the calculator. So we will get an answer of 2.97822 times 10 to the power of negative 37, and this one will become our force of attraction. But we'll neglect this one because the value is too low and it won't affect the value for the force of repulsion. So for problem number 1, our answer is 9.216 times 10 to the power of 12 Newton. So for the next problem, we have here problem number 2. Calculate the distance of separation between two electrons for which the electric force between them is equal to the gravitational force on one of them at the Earth's surface. Given the mass of electron is equal to 9.1 times 11 to the power of negative 31 kilogram, and the charge of electron is 1.6 times 10 to the power of negative 19 coulombs. So first, let's have the given mass of, so for this mass of electrons, we will be using the common mass that has the base of times 10, not the given base of times 11. So we will have for the mass of electrons, we will have 9.1 times 10 to the power of negative 31 kilogram, and for the charge of electron, we have here 1.6 times 10 to the power of negative 19 coulombs. And so first, let's find the value of the gravitational force. So for us to find the gravitational force of the electrons at the Earth's surface, so we will be using this formula. It's the formula for the force of gravity, which is F is equal to mg, where J is the acceleration due to gravity and has a constant value of 9.81 meter per second squared. So Rj here is 9.81 meter per second squared, and then substitute the given value to the formulas. We will have our mass is 9.1 times 10 to the power of negative 31 kilogram times the value of J, which is 9.81 meter per second squared, and plug that one to the calculator. So we will have 8.9271 times 10 to the power of negative 30. So kilogram meter per second squared is also known as Newton. So this is the force between two electrons. And after getting the force, so we'll be able to to calculate the distance of separation between two electrons using the formula for Coulomb's law, which is F is equal to K times Q1 times Q2 over the square of the distance. So what we are looking for is the distance of separation. So we will have this formula: d squared is equal to square root of K times Q1 times Q2 over the value of force. So we have here for the value of K, it is 9 times 10 to the power of 9, and it is in Newton meter squared per Coulomb squared. And for the value of K, we have here 9 times 10 to the power of 9 Newton meter squared per Coulomb squared times the charge of electrons, and it is 1.6 times 10 to the power of negative 19 times 1.6 times 10 to the power of negative 19 coulombs divided by the value of force, which is 8.9271 times 10 to the power of negative 30 Newton. So the value of distance will become, plug this one into the calculator, so this will become, so we will have the value of 5.0802 times 10 raised to negative 15, and this is in meter, so the Newton here will be cancelled out, and so as the Coulomb So we will be left with meter, and that is the distance of separation between the two electrons. It is 5.0802 times 10 raised to negative 15 meter. So for the next problem, we have here problem number 3. The small identical conducting spheres have charges of 2.0 times 10 raised to negative 9 coulombs and negative 0.5 times 10 raised to negative 9 coulombs respectively. When they are placed 4 cm apart, what is the force between them? And if they are brought into contact and then separated by 4 cm, what is the force between them? So for this problem, we have two unknowns. The first one is when they are placed 4 cm apart, what is the force between them? And for the second one, if they are brought into contact and then separated by 4 cm, what is the force between them? So first, let's have the given. So the given distance. So the given distance are in centimeters. So let's convert that one into meter first. So 4 centimeter divided by 100. So that will become 0.04 meter. And for the first charge, Q1 is equal to 2.0 times 10 raised to negative 9 coulombs, and Q2 is equal to negative 0.5 times 10 raised to negative 9 coulombs. So for the first unknown, when they are placed 4 cm apart, what is the force between them? So we will be able to calculate that force using the formula for the Coulomb's law. So it is F is equal to K, Q1 times Q2 over the square of the distance. So, and we all know that the constant value of K is 9 times 10 to the power of 9 Newton meter squared per coulomb squared. So substitute all the given value to the formula, so we will get 9 times 10 to the power of 9 Newton meter squared per coulomb squared times the Q1, which is 2.0 times 10 raised to negative 9 coulombs, and for our Q2, negative 0.5 times 10 raised to negative 9 coulombs divided by our distance, which is 0.04 meter squared. And plug this one into the calculator, so we will get the value of negative 5.625 times 10 to the power of negative 6, and that is in Newton. The meter squared will be cancelled out here, so as the coulombs, and that is the force for the first question, or for the first known. So for the second question, so if they are brought into contact and then separated by 4 cm, what is the force between them? So first, why are they brought into contact? So as we have noticed, the charges of the two spheres in the problem have unlike charges, and from the first law of electrostatics, like charges repel each other and unlike charges attract each other. That means that the two charges of the sphere attract each other, or they have been brought into contact since they have unlike charges. So that means that their charges will be additive. So to get the total charge, we will just add the charges of Q1 and Q2. So this will become Qt is equal to Q1 plus Q2. So our Q1, which is 2.0 times 10 raised to negative 9 plus negative 0.5 times 10 raised to negative 9. So for the value of our total charge will become 1.5 times 10 raised to negative 9. If the identical spheres are brought into contact and then separated, the charges between them will be equal. So this will become Q1 is equal to Q2. And that means we have to divide the total charges into 2. So this will become Qt. That means Qt divided by 2. So 1.5 times 10 raised to negative 9 divided by 2 is 7.5 times 10 raised to negative 10. And from that, we will be able to calculate the force between them using the Coulomb's law. F is equal to K Q1 times Q2 over the square of the distance. So for the value of K, we have here 9 times 10 to the power of 9 Newton meter squared per Coulomb squared, and the value of our Q1 and Q2, which is 7.5 times 10 to the power of negative 10 squared, and that is in Coulomb, and divided by the distance of 4 centimeter and converted into meter is 0.04 meter squared. And convert that one into the calculator, we will be able to get the value of 3.164 times 10 to the power of negative 6 Newton meter squared will be cancelled out, and so as the column. So the FD are both into contact and then separated by 4 centimeter. The force between them is 3.164 times 10 raised to negative 6 Newton. So for the next problem, we have here problem number 4. Point charges in air are located as follows. Positive 5 times 10 raised to negative 8 Coulomb at 0, 0 meters, plus positive 4 times 10 raised to negative 8 Coulomb at 3, 0 meters, and negative 6 times 10 raised to negative 8 Coulomb at 0 to 4 meters. Find the electric field intensity at 3 to 4 meters. So first, let's find, so it is our graph. So to find the electric field intensity at 3 to 4 meters, so first let's find the value of the electric field intensity of E1, E2, and E3. And for us to get that, we will use the formula of E is equal to K times Q over D2. So for our Q here, we will substitute the point charges of A, B, and C. So first, let's have the electric intensity at point charges A. So we have here E1 is equal to, for the value of K, we have here 9 times 10 raised to 9 Newton per Newton meter squared per Coulomb squared. So note that the electric intensity is in volt per meter. So, and for the point charges of A is 5 times 10 raised to negative 8 Coulomb, and for the distance, it is 5 meter because the distance between A to B is 3 meter, and the distance between B to D is 4 meters. So why is that so? Because electric intensity 1 lies in this area, and it passes through point A to B and B to D. So to get 5 meter, so we will just use the Pythagorean theorem, which is square root of 3 squared plus 4 squared, which is 25, and the square root of 25 is 5. So for our electric intensity at 1 is 18 volt per meter. So, and now let's proceed to the electric intensity at this point, the E2. So this one, E2. So in E2, 9 times 10 raised to 9 Newton meter squared per Coulomb squared, and the point charges at E2 is 4 times 10 raised to negative 8 Coulomb, and the distance is 4 meters. Why? Because the distance between B to D is 4, and the graph of the electric intensity 2 lies in this area. It is 4 meter. So for the electric intensity 2, we have 22.5 volt per meter. So, and now let's find the value of this electric intensity at point C. So we have for our electric intensity 3, we have 9 times 10 raised to 9 Newton meter squared per coulomb squared times the point charges at C, which is negative 6 times 10 raised to negative 8 coulomb over the distance of 3 meters. Why? Because um, the distance between D to C is 3 meters. So we have here 3 meters. So for electric intensity 3, we have negative 60 volt per meter. Excuse me. And for us to get the electric field intensity at 3 to 4 meters, so first, let's find the value of this one here, this theta. Because using that value of theta, we can now find the component, the electric intensity of the x and y component, and from the value of x and y component, we can get the resultant of the electric field intensity. So without further ado, let's proceed. So why is it theta is equal to inverse tan 4 over 3? Because the electric field intensity is in 3 to 4, and this 3 here is our x and our R4 is y. So to get the angle theta, so we have the formula for that one is equal to theta is equal to tan inverse tan, which is y over x. So that's why our y is our 4, so it is 4 over 3. So for that, plug that one to the calculator, so we'll get for our theta, which is 53.13 degrees. And from that, let's find next the x and y component, the electric intensity of our x and y component using this formula. So summation of electric intensity at point x, or the line x, which is go back to this one, which is in our x is the point charge at letter A, which is 5 times 10 raised to negative 8. So it is 18 volt per meter. So for that one, for that for the summation of electric intensity at x component, we have 18 cosine theta, which is 53.13 degrees, minus 60, which is our value for our electric intensity 3. And then for the x component, we have the negative 49.2 volt per meter. And for the y component, we have here the summation of y component is equal to 22.5, which is the value of our electric intensity 2, plus 18 sine 53.13 degrees sine, because it is, we are now in a y component. So it is for the y component, we have 36.9 volt per meter. And to get the electric field intensity, so we'll use the resultant formula, which is the resultant formula of square root of the summation of the x component, the square summation of the x component, plus the square summation of the y component. So for the x component, we have negative 49.2 squared plus 36.9 squared. So for the electric electric field intensity, we have 61.5 volt per meter. And that is our answer for this question. The electric field intensity at 3 to 4 meters. And for the next problem, we have here problem number 5. A voltage of B is applied to the inner sphere of a spherical capacitor, whereas the outer sphere is Earth. The inner sphere has a radius of A and the outer one of B. If B is fixed and A may be varied, prove that the maximum stress in the dielectric cannot be reduced below a value of 4B over B. So Earth Earth means Earth here means grounded. So for the spherical capacitor, when the outer sphere is Earth, the formula for in computing the capacitance will be C is equal to 4 pi times the absolute permittivity times the relative permittivity and times the product of A times B over the difference between B minus A. And for we all know that C is equal to Q over V, so the formula will be also replaced with, so C will be replaced with Q over V, so that will become Q over V is equal to 4 pi times the absolute permittivity times the relative permittivity times the product of A times B over B minus A. And also we all know that Q over B is also equal to the electric intensity, so it will also become E is equal to Q over 4 pi times the absolute permittivity over the times the relative permittivity times x squared. So the Q over B, the this Q over B here will be replaced with this one. So the formula will become 4 pi times the absolute permittivity times the relative permittivity x squared times the electric intensity over V is equal to 4 pi times the absolute permittivity times the relative permittivity times the product of A times B over B minus A, and the like terms will be cancelled. So this 4 pi absolute permittivity and the relative permittivity. So we will be left with E is equal to V times AB over x squared times quantity B minus A. And so we will let x is equal to A. So this will become A is equal to V AB, since A may be varied. So that's why we let x is equal to A. So A is equal to V AB over A squared quantity B minus A, and then the A here will be the A above will be cancelled and the A below will become 1. So that will become E is equal to VAB. Oh no, PV. This A here will be cancelled, so we will be left with BB. E is equal to BB over A times A quantity B minus A, and then let's distribute the A here inside the quantity, so that will become E is equal to VB over AB times A squared. To get the electric intensity, so we have to derive this equation in terms of A, so that will become the derivative of A over dA is equal to D over dA quantity VB over AB minus A squared, and then simplify that one using UdV minus VdU. So that will become, the equation will become 0 is equal to quantity AB minus A squared times 0 minus VB quantity B minus tau A over B squared, which is quantity AB minus A squared. So cancel the like term, so we will be left with negative BB quantity B minus 2A is equal to 0, and then simplify that one, it will become B minus 2A is equal to 0. Since A is varied, so we will have the value of A from this formula, so our A will become A is equal to B over 2, and then substitute the value of A to this formula, so this will become E is equal to VB over B squared over 2 minus B squared over 4, and that will become E is equal to VB over B squared over 4, and then B, the B above will be cancelled, and the B squared below will be left with B, and then the simplifying, so we will arrive at the answer of E is equal to 4B over B. And for the next problem, we have here problem number 6. A capacitor consists of two similar square aluminum plates, each 10 cm by 10 cm, mounted parallel and opposite to each other. What is their capacitance in microfarad when distance between them is 1 cm and the dielectric is air? If the capacitor is given a charge of 500 microcoulomb, what will be the difference of potential between plates? And for last one, how will this be affected if the space between the plates is filled with wax which has a relative permittivity of 4? So for this problem, we have three unknowns. So first, the microfarad. So first, the microfarad here has the exponent of -6. Since they have the same exponent, so their exponent will become additive. So -6 minus 6 is equal to -12. So the microfarad will become picofarad. So now let's proceed to the given. So the given distance of 1 centimeter and convert that one into meter. So that will become 0.01 meter. And the area of is also in centimeter and convert that one into meter. So 0.1 meter by 0.1 meter. Since we have the given area and distance, so we will use the formula for the capacitance, which is C is equal to absolute permittivity times area over the distance. So substitute, plug the given value to the formula. So we will have, so by the way, for the value of our absolute permittivity, we have this 8.854 times 10 raised to -12 and multiply to the value of our area, which is 0.1 meter by 0.1 meter, and divided by the value of the distance, which is 0.01 meter. And for our capacitance between, when the distance between them is 1 centimeter, is 8.854 times 10 raised to -12, or 8.854 picofarad. And for the next unknown, if the capacitor is given a charge of 500 picocoulomb, what will be the difference of potential between plates? So what we are looking for this problem is the voltage difference between the two plates. So for that, we will be using the formula for capacitance, which is C is equal to Q over V. And then equating the formula, so we will have V is equal to Q over C. And then substitute the value to the formula. So for Q, we have the value of 500 times 10 raised to -12 coulomb. And for the value of C, which is 8.854 times 10 raised to -12 farad. So for our value for the voltage difference between the two plates are is 56.4716 volts. That is their voltage difference. So for the third unknown, how will this be affected if the space between the plates is filled with wax, which has a relative permittivity of 4? So for this, we will be still be using the formula for the capacitance, which is absolute permittivity times relative permittivity times area over the distance. So in this question, the relative permittivity is given in air, so that means that it is 1. So that's why we didn't include the relative permittivity in this problem, because it is 1. So for this, we already have the value of absolute permittivity over distance times the area. So we will just substitute our our answer to that formula, which is 8.854 picofarad. So for our formula will become C is equal to 4, which is our value of relative permittivity, times the value of absolute permittivity times area over the distance. So that will become C is equal to 4 times 8.854 picofarad, or 8.854 comes from the value of absolute permittivity times area over the distance. So for our for capacitance for this one, so it will become 35.416 picofarad. So it will somehow affect the voltage because the capacitance for this area is smaller than as a smaller value compared to those filled with wax. We can say that our voltage for this one is will be 4 times lesser than the voltage difference of this one. So to prove that one, we will be using the formula of for the voltage difference. So V is equal to 56.4716 volts divided by 4, and that is 14.119 volts. That is the voltage difference when filled with wax. Next problem, we have here problem number 7. The capacitance of a capacitor formed by two parallel metal plates, each 200 cm squared in area, separated by a dielectric 4 mm thick, is 0.004 microfarads. A potential difference of 20,000 volts is applied. Calculate the total charge on the plates, the potential gradient in volt per meter, and also the relative permittivity of the dielectric and the electric flux density. So now let's have the given. The given charge in 0.004 times 10 raised to negative 6, and the given volts of 20,000, and the dielectric 4 mm, convert that one into meter, is equal to 0.004. And to calculate the total charge on the plates, since we have the given charge and the given volts, we will be using the formula for the capacitance, which is C is equal to Q over V, and that equating that one, so that will become Q is equal to C times V, and then substituting all the value to the formula, so we have Q is equal to 0.004 times 10 raised to negative 6 column times the value of the voltage, which is 20,000, and for our Q we have 8 times 10 raised to negative 6, or 8 microcoulomb. And for the second unknown, the potential gradient and volt per meter. So potential gradient is also known as the electric intensity. So for that, for us to have the potential gradient and volt per meter, so we'll be using this formula. Potential gradient is equal to dV over dx. So E is equal to the value of voltage, which is 20,000, and for the value of the electric or the distance is 0.004 meter. E is equal to 5 million, or E is equal to 5 times 10 raised to 6 volt per meter. And for letter C, relative permittivity of the dielectric. So we can get the relative permittivity of the dielectric using the electric flux density. So first, let's have the electric flux density. So using the formula, the D is equal to Q over A, and then substitute the value for Q and A. So we have D is equal to 8 times 10 raised to negative 6 columns divided by the area, which is in 200 centimeters squared, and convert that one into meter by multiplying 1 meter and dividing 100 centimeter, and that will be in squares. So that will become 200 centimeters squared multiplied to 1 meter divided by 100 centimeters squared. So that is 4 times 10 raised to negative 4 coulomb per meter squared. And for letter C, which is the relative permittivity, the value of the relative permittivity, so we already have the value of E, our electric intensity, and the density. So let's apply that one to our formula. So for letter C, we will be using the formula of D is equal to the absolute permittivity times the relative permittivity times E, and manipulating that one, that will become relative permittivity is equal to the density over electric intensity times the absolute permittivity. And substituting the value to the formulas, we will have for the relative permittivity is equal to the value of density, which is 4 times 10 raised to negative 4 coulomb per meter squared, and the value of our intensity, which is 5 times 10 raised to 6 volt per meter, times the absolute value of permittivity, which is 8.854 times 10 raised to negative 12, and the value of our relative permittivity is 9.035.